Welcome back. In this section, I'll be talking to you about the metabolism of two other hexoses, that is fructose and galactose. So why is it important? Again, it is because of the disease that we have to know about the metabolism of fructose. So what do you know about fructose? Now fructose, where is it present? What are the sources of fructose in the diet? What are the sources of fructose? Fructose can come from the diet. That is one of the biggest sources of fructose. From which are the diets which contain fructose? Naturally, you must have heard that fructose comes from fruit sugar. So it is present in fruits. What else? Where else? Now, there is something called as high fructose syrup which is added to soft drinks. So soft drinks also sometimes, depending upon their composition, will be containing high amounts of fructose. Fructose is also present in honey, and fructose also comes from an important source, that is sucrose, and sucrose is table sugar. So we have different sources from which fructose comes through the diet. What happens to this fructose? This fructose is absorbed from the intestine. So then what happens? Does it stimulate insulin release? Fructose does not stimulate insulin release. Fructose is insulin independent. The metabolism of fructose does not depend upon insulin at all. So let us see how it is metabolized. So as I said, it comes from the diet and it does not stimulate insulin secretion, and its entry into the cell is also not insulin dependent. Where is it metabolized? Naturally, liver. Liver is the main site where the metabolism of most of the hexoses or any compound takes place. As I said, everything takes place in the liver except ketolysis. So liver is one of the important sites. Other than that, it also takes place in the kidney and in the small intestine. Now, there are two main enzymes which are required for fructose metabolism, and the deficiencies of these two enzymes are also associated with two diseases. Two enzymes, two diseases. So, what is the main function of this? I will be just writing to you about it. The first enzyme is which converts fructokinase. The first enzyme is the one which converts fructose to fructose 1-phosphate. Look at the difference. The difference is usually hexokinases and all will convert glucose to glucose 6-phosphate, whereas here it is converted to 1-phosphate, and the enzyme is fructokinase. Kinase again requires ATP. Now the other enzyme that is there, once fructose 1-phosphate is formed, this is broken down, and this is broken down by an enzyme which is similar to the enzyme found in glycolysis, that is also aldolase. The name is also aldolase. Only thing is the enzyme aldolase which is found in glycolysis is aldolase A, and here it is called as aldolase B. Aldolase B. What are the products that are formed here? The products that are formed are dihydroxyacetone phosphate and glyceraldehyde. I have written it out here. Produces DHAP, dihydroxyacetone phosphate and glyceraldehyde. So what? DHAP, what can happen to it? Dihydroxyacetone phosphate, where have you heard of it? It is an intermediate of glycolysis. So what? That means fructose can enter into glycolysis. What is the importance of this? Fructose will further be metabolized by entering into glycolysis. So what has happened during this? When it enters into glycolysis, what has happened? It has bypassed two important regulatory enzymes of glycolysis. Which are they? The phosphofructokinase 1, PFK1, and glucokinase or hexokinase, the first enzyme. Both these enzymes were regulatory enzymes which regulated glycolysis. These both have been enzymes have been bypassed, and it has gone into glycolysis. So will it be beneficial to anybody? Yes, in a way it should have been theoretically very beneficial, because once it bypasses, it can give out energy, and this will be a boon to the diabetics. You give them fructose, it will be very helpful, and they may help them to get energy. But there is a slight problem in this. It has been found out experimentally that giving high fructose diet to a diabetic will flood the pathway, and it will not only flood the glycolytic pathway, it will lead to increase in LDL cholesterol, increase in free fatty acids, and finally increase in LDL cholesterol, which are much more atherogenic and much bad for the diabetic patient. Hence, high fructose diets also are not recommended for a diabetic patient. That's why we are going to learn about this fructose metabolism. I am emphasizing on this. Now, the one more product that is formed, that is glyceraldehyde. What happens to it? And that is the reason why we cannot advise high fructose diet for a diabetic. So, DHAP can enter glycolysis, or it can go into gluconeogenesis also. Remember, once it has gone into glycolysis, it can be either way. It can go into glycolytic pathway or go into gluconeogenesis. But glyceraldehyde is converted to glycerol, and glycerol can be used for gluconeogenesis. So in a diabetic, again, it has gone back and it has produced more glucose, or more importantly, it can form the substrate for triacyl glycerol formation. Triacyl glycerol means there is more fatty acid formation, more LDL formation, and it becomes more atherogenic. Now, what is the function of fructose in the body? Now, free fructose is seen in seminal plasma. It is secreted by the seminal vesicles, and it acts as a source of energy for the sperm. So that is why it is important in the body. So can it be produced in the body without taking it in the diet? Yes, there is a pathway by which from glucose itself we can produce fructose. So glucose can be converted to fructose via the formation of an intermediate sorbitol. Sorbitol is the intermediate. This is called as the polyol pathway. Remember, sorbitol can form fructose and sorbitol can form glucose. This sorbitol, this aldehyde, dehydrogenase is required. Glucose is converted to sorbitol. Sorbitol can form fructose. So again, this free fructose can be produced even if the diet does not contain fructose. The body has a mechanism by which it can produce fructose from glucose. Why is it necessary? As I said, to give energy to the sperm, where it is very important. Now, other than it is secreted by seminal vesicles, there is a condition called as azoospermia. Now, in azoospermia may be due to the blockage. If we want to know where the block is, whether it is above the seminal vesicles or below the seminal vesicles, we can estimate fructose in the semen. If the fructose is present, the block is above the seminal vesicles. Remember, it is the seminal vesicles which are secreting free fructose into the seminal plasma. And this is important to keep the semen in the liquefied state and to give energy to the sperm. Now we go on to the disorders of fructose metabolism. Which are the disorders? Two enzymes are involved. That is, one is fructokinase and aldolase B. What will happen if fructokinase is deficient? What will happen? Nothing will happen. Fructose will accumulate. So what? Fructose can be excreted into the urine. So what? Nothing will happen. Wherever fructose is required, it will be produced from glucose. So there won't be any problem. This is very benign condition. If fructokinase is deficient, we don't mind if none of these happen, if it does not enter the glycolysis pathway, does not form gluconeogenesis, nothing of this matters. So if fructokinase is deficient, it is a very benign condition. Okay, so we call this as essential fructosuria. Essential means there is no other way. It has to be excreted out. So fructose is excreted into the urine. Whenever fructose levels rise, it gets excreted into the urine. We call it fructosuria. It is a very benign condition, and it is an autosomal recessive condition, a genetic condition. It does not cause problems. Which is the other enzyme which can cause problems? Thus, aldolase B. If aldolase B is deficient, what will happen? It will cause accumulation of fructose 1-phosphate. So what? Where will it accumulate? It will accumulate in the liver. So what? Again, that brings us to the question, what will happen if fructose 1-phosphate accumulates? What can happen? Nothing. Can it be excreted through the urine? Remember, all the phosphorylated hexoses, once they are phosphorylated, they are sort of trapped in the cell. They cannot leave the cell freely. They do not have any mechanism. There is no gate in the cell membrane which can throw out this fructose 1-phosphate. So it has essentially will cause problems, especially because of the accumulation of fructose 1-phosphate. Please remember, here one phosphate is required. Phosphate has been added. From where did this phosphate come? It has come from the cell stores only. So the inorganic phosphate, most of the inorganic phosphate will be sequestered, will be utilized, will be captured, will be trapped as fructose 1-phosphate. So the inorganic phosphate levels within the cell will decrease. So what? Remember, we need one more important compound which is phosphorylated, and which is that? That is ATP. So if there is no phosphate, what will happen? ATP will decrease. So we have a whole gamut of reactions that are happening just because inorganic phosphate is sequestered in the form of fructose 1-phosphate. We call this condition, one more name that is given for this, when aldolase B is deficient, we call it hereditary fructose intolerance, also called as fructose poisoning. We have been poisoned because of fructose poisoning. This is also an autosomal recessive. The lack of enzyme is aldolase B. Please look at the slide. Now, when do the first symptoms appear? Will it appear in the baby? Will the baby be alright? Usually, yes, the baby is alright. Why? It is having lactose. It is based on only milk diet. There is no fructose which has come into the baby's mouth or into the diet or into the bloodstream. There is no fructose, no source of fructose. So nothing will happen till it is weaned. Once the baby is weaned, the symptoms start appearing. Okay, so the first symptom starts appearing after weaning. So fructose 1-phosphate accumulates, and there is sequestration of the inorganic phosphate. ATP decreases, AMP rises, adenosine monophosphate levels rise. So what? The body starts degrading AMP. When AMP is degraded, what happens? When any nucleotide is degraded, what is the end product? It leads to uric acid formation. So finally, it will lead to hyperuricemia and its problems. Can we stop this? Yes, it is a simple matter for removing fructose and fructose related diet from the do not give fructose in the diet. That will be very much sufficient, and it can prevent so many symptoms of hereditary fructose intolerance. Remember, there is no ATP, so gluconeogenesis is affected. So there will be, whenever gluconeogenesis, remember, in a baby, especially in a baby, it is required for maintaining the blood glucose levels early in the morning. So what we call this as fasting hypoglycemia occurs. So fasting hypoglycemia, plus there will be vomiting also. There won't be any protein synthesis, blood clotting will be affected. All these things happen because there is no ATP. Now, other than this, just the removal of fructose from the diet is definitely very helpful in hereditary fructose intolerance or aldolase B deficiency. How can we diagnose this? Basically, it is by looking at the fructose levels in the urine, because fructose will be excreted in the urine, and plus, more importantly, there is one RFLP, that is restriction fragment length polymorphism, which can be done to look at the disease condition itself and the clinical symptoms, which will help in diagnosis. We go on to the metabolism of another hexose, galactose. Let me start with galactose. Galactose. What is it? It is a C4 epimer of glucose. So where does it come from? What is the source of galactose? Lactose. Milk products all contain lactose. Lactose is made up of glucose and galactose, and hence galactose will come into the bloodstream. Can it be got from any other sources? Yes. Any complex carbohydrates, like glycolipids, glycoproteins, etc. When they are degraded, glycosaminoglycans are degraded, galactose is released, and this also has to be metabolized. So which are the enzymes involved in the metabolism of galactose? Again, it is similar to fructose. So we have galactose, which will be converted by galactokinase, and it will be converted to galactose 1-phosphate. Again, this is also galactose 1-phosphate. what happens to it? Can it enter the glycolytic pathway? Unfortunately, no. There is no other something which can break out galactose 1-phosphate. So we have what is called as galactose 1-phosphate uridyl transferase. A big name, big enzyme. What does it do? What exactly is done is galactose 1-phosphate is converted into UDP galactose. So it means it requires UDP. From where did it come? UDP galactose came from UDP glucose. UDP glucose will donate its UDP to glucose, get to galactose 1-phosphate and convert it into UDP galactose, and this will be forming glucose 1-phosphate which can be further metabolized. So UDP galactose. Once this is formed, so what? So the UDP galactose will be used for the synthesis of different products. Like it may be used for the synthesis of lactose. It may be used for the synthesis of glycosaminoglycans. Wherever it is required, glycolipids, glycoproteins, etc. UDP galactose can act as the donating agent. Remember, it is having high energy UDP, so galactose can be used. But if it has to be degraded, we have one more enzyme which will convert it back into UDP glucose itself. UDP galactose can be converted into UDP glucose. So what is happening here? Galactose to glucose, it is epimer. So it is an epimerase. So we call it UDP galactose 4 epimerase, because that is in the 4th position the epimerization is taking place. So UDP galactose 4 epimerase can reconvert it back to UDP glucose, which can be further enter into this cycle. So it is a simple metabolic pathway of galactose, but there are certain enzyme deficiencies which can lead to galactosemia, etc. I'll be talking about this now. So as I said, UDP galactose is used in the synthesis of glycoproteins, glycolipids, glycosaminoglycans. So which are the disorders? Now the first disorder could be galactokinase, galactose to galactose 1-phosphate. So you have galactokinase. What will happen if galactose accumulates? This also can increase in the blood, and galactose is excreted out into the urine. What do you call it? Galactosemia, galactosuria. One more thing that can happen with galactose is this galactose can be converted by the alcohol pathway. Just like fructose was converted into sorbitol, galactose can be converted into galactitol. We call it galactitol. It can be converted into galactitol. So formation, this again requires galactitol. Please look here. Formation of galactitol requires the enzyme aldolase reductase, and this aldolase reductase is present in the liver, kidney, retina, lens, nerve tissue, seminal vesicles and the ovaries, and this is where galactitol can form. So if there is increased galactose, more of galactitol. So what? Galactitol, again it is a hygroscopic and can lead to cataract. That is the importance of galactitol. Now one enzyme I said where galactokinase is deficient, but similarly, if this does not take place and galactose 1-phosphate is not converted to UDP galactose, there is one uridyl transferase here. So if this enzyme is deficient, we call the condition as classic galactosemia. So the enzyme is galactose 1-phosphate uridyl transferase. This is again an MCQ, galactose 1-phosphate uridyl transferase. So galactose 1-phosphate will accumulate. The symptoms are same as that of fructose 1-phosphate. Whenever fructose 1-phosphate accumulates, the same things can happen even with galactosemia, classical galactosemia. This is also an autosomal recessive. Again galactosemia, galactosuria, and accumulation of galactose 1-phosphate and galactitol in the nerve, lens, liver and kidney tissues. And these kids are usually born with congenital cataract. This is one of the characteristic feature of classic galactosemia, because galactitol can accumulate in the lens, it is hygroscopic and can lead to congenital cataract. That is one classic feature of classic galactosemia. As I said, one important thing that can happen is UDP galactose can be used for lactose synthesis. I'll just add one word about lactose synthesis. When does it take place and how it is taking place? Remember, for the transfer of UDP galactose for glycosaminoglycans or glycoproteins or for anything, we need a transferase protein, and this is known as UDP galactose transferring protein. Okay. Now this enzyme will transfer galactose from UDP galactose to whichever protein it wants. It may be a protein, it may be a lipid or aminoglycan, glycosaminoglycan, where galactose is transferred. What is happening during lactation? During lactation, lactose has to be synthesized. So that means UDP galactose has to be transferred to glucose. Normally this does not happen. So how is this transferase modified? That enzyme which transfers galactose to glucose, galactose to any compound actually has a monomer initially, and that is known as protein A. It is just called as galactose transferase protein A. This is present in all the tissues. Now, whenever there is lactation, under the influence of prolactin, one more protein is produced in the lactating mammary gland. This is called as protein B. Only when protein B is present, it will combine with protein A, and then the specificity of the enzyme changes. It can now transfer UDP galactose to glucose and form lactose. So the importance is that the protein B is under the control of prolactin, and this happens in all the mammals and especially during the lactating period and in the mammary gland. So it is only in the mammary gland that this reaction can take place. It is only in the mammary gland that the protein B is present. So UDP galactose is transferred to glucose only in the presence of protein B, which is under the control of prolactin. So I'll just talk to you briefly about glycosaminoglycans. We have told about it. Metabolism is not important. I'll be just telling you about the disorders. Again, exam point of view, please pause the button here and look at the different names and the different enzymes that are deficient in these glycosaminoglycans. With that, if you look at this, we come to the end of the different carbohydrate metabolisms. All the different carbohydrate metabolisms. I'll be talking more about diabetes mellitus and its investigations after we complete lipid metabolism and protein metabolism. That will make more sense at that time when we talk of all the three metabolisms together. Now first I want you to pause and look at the disorders due to the deficiency of different enzymes, and these are called as mucopolysaccharidosis. And all these mucopolysaccharidoses are characterized by one thing, and that is mental retardation, skeletal deformities. These are always present, and mental retardation means the enzyme has to be estimated. Other than from exam point of view, clinically it is very difficult to differentiate between the different mucopolysaccharides. It is only by doing the enzyme assay that we can differentiate the different mucopolysaccharidoses. With this, I want you to look at the different disorders. Please look at these disorders. Hurlers, Hunters, Sanfilippo's, Moriquios, Skis, Morotox lamis, and Slice. This is just from the viewpoint of examination that you have to know the enzyme deficient.